Chapter 8, Reading Roofs. Our lesson objectives: list relevant roof definitions, describe the 8 most common roof styles, strengths, and hazards, identify the most common roof coverings, and list the various types of roof appendages. In this chapter, we're going to examine the importance of reading roofs, the 8 most common roof styles, unique roof construction considerations, roof covering, roof appendages, and of course, your chapter review exercise. The roof of a structure is normally 1/5 of the primary components of a building. And fireground operations are usually conducted below and or above the roof. Knowing the type of roof and its potential structural integrity can directly affect fireground efficiency and safety. Also, the roof can help identify the era of the house when it was constructed. There are 3 general roof categories: East Coast, West Coast, and No Coast. Key factors to look at, of course, the era the home was constructed, what shape the roof is in, as well as the aging. And of course, with the aging, it's important to note that a lot of times on East Coast style roofs, those roofs have multiple layers of asphalt shingles, which increase the dead load tremendously. Often at the fascia board, you can see anywhere between 2 or 3 layers of shingles on the roof. Let's review some key definitions that are important to have a good knowledge of when covering this chapter. First, attic. An attic is a large space that is created by a steep pitched roof, often arched or gable. This is done for drainage and or appearances. Depending on the type of construction, attics are normally large enough for storage and can be modified for additional living space and sometimes contain HVAC and other mechanical equipment. Next definition, component connections, also known as framing junctions, where 2 or more structural members are joined, and for this chapter, how they are joined. As an example, a connection can be secured by nails, bolts, steel plates and bolts, metered finger joints, gusset plates, and other means. The way structural members are joined can determine how long the connection will last under fire conditions. Next term, conventional construction. That is solid lumber of 2 by 6 inch or larger used in standard framing configurations. Cockloft. A cockloft is defined as a small space that is created when a roof is raised above the level of the ceiling joists and rafters to provide a pitch for drainage. Cocklofts are common in older buildings between the 1800s and the early 1900s, and they are normally of conventional type construction. Dead load. The weight of the building itself and anything permanently attached to the building. Diagonal sheathing. This is a series of 1 by 6 inch boards that run at a 45-degree angle from the exterior walls to the primary structural members and provide increasing structural stability as they cross more roof structural members. This style of sheeting was favored after the 1930s. Engineer wood. Wood products made from a composite of glue and veneer and or wood chips that are pressed together to form components that replace sawn lumber, sheeting, and other structural materials. Common examples are I-beams and OSB. Jack rafter. They are roof rafters used in hips or valleys to span between ridge boards or wall plates. Light weight construction. Solid or engineered products used to form assembly-built structural elements that are lower in mass than previous construction methods. Lightweight trusses. Trusses that are comprised of members of less than 2 by 4 inch or smaller and are often made from engineered lumber or metal. Live load. Any load applied to a building other than a dead load. Live loads are typically transient in moving, impact, or static, like furniture. Examples include people, snow, and wind. These loads add to the existing dead load of a building, but are not permanent parts of the structure. Roof, slope, and pitch. This refers to the degree of slope or pitch for a roof and is expressed as a ratio. For example, a 14-12 pitch means that the roof is 4 inches vertical for every 12 inches of horizontal distance. Sheeting. All manner of material used to cover or encase walls, ceilings, and roofs of frame structures. For a roof, it is the first layer of covering for joists, trusses, structural beams, or rafters, and is found in solid or open sheeting arrangements. Solid sheeting arrangements include OSB, plywood, or other panels, as well as solid boards that are butted tightly together. Open sheeting, often called skip sheeting, is formed when boards, usually 1 by 4 or 1 by 6, are laid on the roof with 4 to 6 inch gaps between each. In most cases, sheeting increases the stability of a building roof. Straight sheeting, a series of 1 by 6 inch boards that run at a 90-degree angle to support structural members. Timber truss. These are large dimension lumbers used to form a truss. They are commonly found in older roofs. This type of construction is normally made from full dimension lumber and is often comprised of multiple members bolted together to form one structural member. Truss, an engineered structural element that uses groups of rigid triangles to distribute and transfer loads. The triangles create an open web space. Trusses are used in lieu of solid beams in many buildings. A typical truss is comprised of one or more triangular units constructed with a straight member whose ends are connected at joints, referred to as nodes. A triangle is the smallest geometric figure, which will not change shape when the sides are fixed. Finally, truss loft, an attic space created by the open web nature of the trusses. The 8 most common roof styles, in no particular order, are gable, hip, flat, bridge truss, arch, sawtooth, gambrel, and monitor. Let's start with the gable roof. A gable roof is perhaps the most popular style of roof in the United States, as there are literally millions of residential single-family occupancies with a simple to construct and attractive roof. The term gable is derived from an A-frame configuration. Two slope or angled surfaces between two flat ends. The two most common methods of construction are conventional and lightweight, or considered truss construction. Conventional construction is often referred to as stick frame construction, as this name is derived from the fact that each member is literally built stick by stick. A variation of the gable roof is the bungalow construction. The bungalow construction, which uses a rough sawn 2 by 3 inch or 2 by 4 inch rafter, which is spaced up to 36 inches on center, are butted together at the ridge without a ridge board, and typically use a 1/4 inch space sheeting nail to the rafters. As you can see in figure 8-3, there is a typical bungalow style construction versus 8-2, the A-frame construction of the gable roof. Again, notice how the gable roof has that rafter running at the peak, and the bungalow style does not. The lightweight gable roof construction is different from our coarse or traditional, and that is because it uses traditionally metal gusset plate connectors, which may vary in size and thickness and depth of penetration. However, 18 gauge steel plate with prongs at 3/8 inch are most common. More recently, glue has replaced the gusset plates in both residential and commercial truss applications. Another variation of truss construction is trusses made from metal. This change is gaining popularity due to the increasing cost of wood and the resistance to degradation from weather and termites. The lightweight construction is basically held together with, as I said, glue or some sort of metal gusset plates, and it is shown through testing that they do not hold up well to fire conditions. In the text, they did not name the fire department, but they claim that they did some unofficial scientific testing where the glue trusses were exposed to temperatures and began separating and failing at 350 to 400 degrees. So now let's look at some of the strengths and hazards from this type of roofing. When we look at the strengths of both of these styles of construction, the only one that really can have a strength, or one that's listed in the text I should say, is that of the conventional construction that uses the ridge boards and rafters of 2 by 6 inch or larger, and of course it is nailed together instead of using the gusset plates or glue. This type of construction can last approximately 4 times longer than 2 by 4 pieces of lumber in trusses when they are exposed to fire. The stronger areas of this roof are the ridge and valley, and the areas where the rafters cross the outside walls. When we look at hazards, what we're really concerned is that lightweight construction, because they will only last 1/4 the time of conventional trusses as a rule of thumb. Again, because they're exposed to fire and heat, and they're only held together with metal and glue. And once they get heated, they lose their integrity and leads to failure. It is important to note that newer roofs use 7/16 inch or 1/2 inch plywood or OSB as sheeting instead of the plywood. The OSB does burn faster, which leads to a faster fail time. than the spaced sheeting and offers minimal resistance to fire. One of the greatest hazards is misidentification of a lightweight construction roof. Identification can be enhanced by an intimate knowledge of your district and pre-fire planning. Actually, the presence of 2x4s and rafter tails under the eaves is an excellent indicator of lightweight truss construction. Please be aware that trusses may be modified on commercial buildings to look like 2x6-inch rafters on the front side of the building, but in the rear they are normally not modified. Often you can look at the rear building, and this will allow you to see the real size of the rafters used in the building. Hip roofs next. The hip roof is similar to the gable roof, but the flat sides of the A-frame are replaced with a sloped roof. The hip roof appears more like an irregular pyramid. Similar to the gable, conventional hip roofs consist of a ridgepole, and then hip rafters are installed from the ridgepole down to and across the corners of the outside wall. Valley rafters are used where two roof lines are joined. Jack and common rafters complete the structural members. The ridgepole and rafters are typically 2x6-inch or larger, with rafters 16-inch to 24-inch on center. Rough sawn 2x3-inch or 2x4-inch rafters and 36-inch on center were also used in the older wood frame structures. Although not as common as it used to be in gable roofs, in lightweight construction, the construction materials, both wood and metal, are similar to those used for gable roofs. Various degrees of pitch and roof coverings are characterized on this style of roof. Strengths. In conventional construction, the ridges and rafters are 2x6 or larger. The ridgepole, valley rafters, hip rafters, and the area where the rafters cross the outside wall are the areas of greatest strength. Hazards. The hazard of hip roofs are similar to those of gable roofs. The presence of 2x3-inch or 2x4-inch trusses for rafters will produce results similar to those of lightweight trusses in gable roofs when exposed to fire. Although the spacing of the trusses may be reduced for truss, gable, and hip roofs covered with tile or other such heavy material, the collapse potential will be enhanced due to the increased dead load on the roof. Similar to the gable roof, reading the rafter tails can be an excellent indicator of the size and spacing of the rafters. Gambrel roof. A gambrel roof, the name is derived from the Latin word gamba, which means horse, hawk, or leg, is an attractive design that is very identified to its unique shape. As you can see in figure 8-7, the gambrel roof is two-sided with each side slope broken by an obtuse angle at the lower slope is steeper than the upper slope. This design is popular due to its ability to provide the advantages of a sloped roof for rain and snow runoff while also providing maximum headroom in the area below the roof. The most popular use of this roof design is found on barns on many farms in this country, but it is also used on some residential and commercial buildings. Although a gambrel roof can be constructed from either conventional or lightweight construction method, most of these roofs have been constructed from the conventional construction. A variation of the gambrel roof is the Mansfield style roof. The difference in the two is that all sides of the Mansfield roof share a hip style slope. Much like the difference between the gable and the hip roofs, the gambrel roof has flat walls that rise to the peak on opposite ends, whereas the mansard has hip slopes on all sides that rise to a secondary slope from the ridge top. A mansard roof is often characterized by dormer windows that protrude from a steep slope of the lower pitches. Older gambrel roofs are likely conventional construction, and newer gambrel roofs may use lightweight construction. In the presence of lightweight construction, it is apparent in a roof. It was also likely used in the construction of the floors. If there is a noteworthy amount of storage in a gambrel loft area, this could be a significant hazard for personnel working below the loft area. Determining the extent of fire in a gambrel attic, it is easy to visualize what an involved heavy load of storage would do to supporting lightweight structural members. Roof ventilating operations would be extremely difficult due to the design of a gambrel roof, unless attempted by an aerial device. Monitor roofs. Monitor roofs have customarily been used on barns and some commercial buildings, but their design affords many advantages for a wide variety of buildings such as garages, dwellings, and some other buildings, hence their development popularity. A monitor roof is basically composed of two shed-type roofs that are separated by a center section that is raised above the shed roof and supports a gable roof. The raised center section is customarily flanked by windows or eave lights along the sides for daylight and ventilation. The advantages of lighting and ventilation can only be a benefit for commercial buildings, but can also be used for offices, storages, or extra sleeping areas. A side benefit is the center section can provide the necessary height for such things as RV storage. Construction can vary, but is typically dependent on the era of construction. Older buildings used conventional construction of 2x6 or larger structural members and were often integrated with pole barn type constructions. Older buildings also typically use conventional type construction and materials to finish the interior. While newer, modern buildings can still use conventional construction, lightweight construction is increasingly used as a cost-reducing measure to construct these buildings with the same external characteristics. This consideration can include veneer wood-based materials and corrugated type materials, including corrugated metal or fiberglass exterior panels. In some cases, it is not unusual to find the lower portion constructed of substantial structural members and the raised center section constructed of lightweight material. The shed and gable roofs can either be conventional or lightweight construction. The corrugated metal fiberglass exterior siding will be readily fail when exposed to heat and or fire, as will the veneer wood products on these structures. The large open areas in monitor buildings will enhance the horizontal and vertical extension of fire and smoke. Consider the feasibility of using the upper window eaves in monitor buildings for vertical ventilation. A diverse interior fire load can be expected in monitor roof buildings and vary widely from farm animals, hay, and RV storage to offices and multiple commercial occupancies. The upper portion of a monitor building may be occupied and needs to be searched. If vertical roof ventilation is necessary, the monitor shed roof will be easier to ventilate than the upper gable roof, which will likely require the use of an aerial device. Sawtooth roofs date back to the late 19th century and were typically used in manufacturing and industrial building as a primary light source, before daylight was replaced with electrical light sources. The roof remains popular through the 20th century and began to disappear around the 1940s. The sawtooth roof is a roof system that is unique in that it is comprised of a number of triangle, and parallel roof surfaces, with glass sides often facing away from the equator side of the building to capture a diffused light source. Additionally, as warm interior air rises, the windows can be used for interior ventilation if they can be opened. This roof is commonly constructed with rafters of 2 by 8 inch or larger and can use wood and or metal support for bracing. The sloping portion is characteristically covered with 1 by 6 inch sheeting and composite roofing material. This type of roof is constructed basically the same today as it was in the 30s and 40s, with the exception of the sheeting. Numerous support posts are required with the sawtooth design, increasing the strength of this roof as compared with a comparable flat roof with larger open areas. If this roof is constructed today with modern material, expect lightweight construction that is covered with a 1/2 inch plywood or OSB. Sawtooth roofs are normally of older design and construction. Early collapse of main structural members of conventional construction for sawtooth roofs should not be a primary concern. Typically, the complete underside area of a sawtooth roof is exposed to the building content. Numerous supporting posts are required with a sawtooth design, which can increase the strength of this roof as compared to a similar sized flat roof. The sawtooth is very stout and can usually support the weight of ventilation operations. Removing numerous windows can achieve the desired result. Our only real hazard here, if this is built today, then you're going to have the lightweight construction, which uses the OSB sheeting or the smaller plywood, which has little fire resistant characteristics. Flat roofs, general. The simplistic flat roof has developed into a very popular style roof for a wide variety of structures. Instead of constructing a gable, hip, gambrel, monitor, sawtooth, or arch roof, just erect 4 walls and cover them with a flat roof. This is a cost-effective design when considering labor constraints, and even more cost-effective when lightweight materials are used. Although simple in appearance, flat roofs can also be deceiving, as they can vary in construction methods and can hide modifications to the basic roof components, often making it difficult to determine which type and or method of construction has been used. A variation of a flat roof is a shed roof, which is nothing more than a flat roof that has been constructed with a pitch that exceeds 10 degrees. A low pitch is defined as 10 to 20 degree angle, and most sheds are constructed with a pitch exceeding 20 degrees. Shed roofs are common on sheds of various sizes, but also constructed on some residential and commercial buildings for a specific architectural appearance that requires the walls to increase in slope from the short end to the high end, and the ability to place windows for daylight on the wall at the high end of the slope. The focus on foreground is to try and identify the type of flat roof encountered based on prior knowledge of a particular roof, the style of the building, the era of construction, and additional information from interior and exterior personnel. The wide variety of flat roof construction types can be categorized as followed: conventional, wooden I-joist, open web construction, metal gusset plate construction, panelized, open web board joint, and non-structural lightweight concrete. Conventional flat roofs. A true flat roof has a pitch angle between 0 and 10 degrees, with a minimum of 6 degrees, which is recommended for drainage. Wood rafters or joists of various sizes are usually laid across the outside wall. However, in some cases, rafters may also be suspended by metal hangers. Rafter joists in conventional flat roof configurations may or may not have internal, horizontal, and/or vertical support. The primary method for connecting structural members is a metal plate and bolt and/or nails. Some older roofs have bridging or scissor bracing between the joists to increase lateral stability. On-center spacing for rafters is typically 2 feet. The rafters are covered with a 1 by 6 inch sheeting of plywood or OSB, again with newer applications, and uses composite roofing materials such as rock or other similar material. Older conventional flat roofs on masonry construction commonly used lets in the walls to support the rafters and joists. This is an old method, pre-World War II, that is no longer used. Newer buildings use a ledger bore that is connected to the load-bearing walls. All the strength hazards and summary considerations for flat roofs are the same as for your shed roofs. An older conventional flat roof can be considered substantially compared to that of a modern roof. Unreinforced masonry buildings commonly use lets or pockets in the walls to support the rafters and joists for flat-type roofs. The older the building, the greater the possibility of multiple layers of roofing material that the roof was likely not designed to hold. In some cases, roof ventilation operations might be able to be conducted within close proximity to the fire on a conventional construction. Flat and shed roofs can be covered with a wide range of materials such as composite metal, rock, slate, tile, membrane, and many others, to name a few. Flat roof with wooden I-joists. These are wooden I-joists, also known as engineered wooden I-beams, and of course those were developed over 40 years ago, and their dimensional stability assisting in helping them to resist warping, shrinking, and twisting. Additionally, they are lightweight and come in long length. These traits have made them very popular in both floor and roof construction. I-joists consist of 3 main components: the top chord and the bottom chord, and a stem or closed web in the middle. They are most commonly seen are top and bottom chords that measure 2 by 4 inch or 2 by 3 inch. Some chords may resemble plywood due to the horizontal laminations. Strengths. The strong area of this roof is at the perimeter where the roof ties to the building. The hazards are threefold. 1. The 3/8 inch stem and the 2 and 3 inch or 2 by 4 inch cords will take little time to burn, weaken, and cause rapid collapse of any cords and roofs sufficiently undermined by fire. Unfortunately, many buildings can be found with unprotected cords. They are often painted a dark color to minimize their presence. 2. The glue used to form OSB and also used for webs can degrade with convection heat. The glue is hydrated, and once the moisture is steamed off, the glue turns to dust. Third, a common practice is to run heating and air conditioning ducts of various size through the web. This practice removes a significant portion of the stem and gives fire horizontal access to adjacent I-beams, enhancing the extension and weakness of the exposed material. Flat roof with an open web construction. Open web construction consists of a top and bottom parallel wood cords crossed, connected by steel tube web members. Another version of this construction is construction of all metal in the same configuration and is referred to as open web steel joist. In both versions, the top cord that is under load offers a bridging effect, causing it to be in compression, and the bottom cord the unsupported side, to be in tension. The OWC is prefabricated at the factory before installed and is constructed either with parallel cords laid on the edge or flat laid cords. The steel tube web members are prefabricated from 1-inch to 2-inch cold rolled steel tubings. The ends are pressed into a semicircular shape with holes punched through them. These flattened ends are inserted into the slots in the cords and steel pins and then are driven through. Strengths. The strongest area of this roof is in the perimeter of the building where the roof ties into the exterior walls. Hazards. As with most lightweight construction, the hazards of this roof are numerous. It is basically constructed under compression and tension with sheeting in plywood or OSB. These components offer minimal resistance to fire. The cord members are exposed in the interiors of some structures, increasing the exposure hazard to the roof. Unlike conventional construction, the open space between the top and bottom cords will promote lateral extension of fire, resulting in early collapse of the roof. Flat roof with metal gusset plate construction or glue. This type of truss is the most common type of lightweight truss, and it is a favored method of roof construction for both residential and commercial structures, large and small, across this country. Trusses for roofs are constructed in a wide variety of styles, but all of them share common features. Lightweight wood trusses are predominantly comprised of 2x4s held together by the metal gusset plate connectors that are again typically 18-gauge steel plates with prongs of 3/8-inch penetration. You might want to remember that. And it is used in a wide variety of wood truss application. One note, while metal gusset plates are often called gang-nailed, we avoid the term because it grants the connection too much integrity. You may encounter 2x4s in the spans of up to 80 feet. This sheeting is usually a 1/2 inch in plywood or OSB. Strengths. The strongest portion of this roof is in the area where the trusses terminate on the outside of the bearing walls or across them in the cantilever applications. Hazards. Extensive use of 2x4s in trusses with the gusset plates equals short burn time and early failure of a roof. As the truss members are under compression and tension, when the bottom quarter webbing fails, one or more trusses can also give way, causing a rapid collapse. Metal gusset plates or glued joists, when exposed to fire or high heat, in addition to the metal gusset plate, it is easy to visualize that if trusses are encountered that are glued together and glue melts at a moderate temperature, collapse will also occur quickly. And of course, the sheeting of the smaller plywood or the OSB will burn and fail at a faster rate than traditional construction methods. Flat roof panelized. This roof is only found west of the Mississippi and is the most predominant on the west coast, where wood was plentiful and is commonly found on wood, masonry, or concrete tilt-up slab buildings. However, due to the rising cost of wood, this roof is being replaced with steel open web bar joist roofs. There are two panelized roof systems, all wood and hybrid steel. Strength. The strength of the wooden roof and its beams, the purlins in the regions along the building perimeter. The strength of the hybrid roofs are at the girders and the primary steel trusses in the regions along the building's perimeter. Your hazards. Hollow steel pipe of 4-inch diameter can be found supporting the span of wood beams or girders, primarily steel trusses. Expect weakening or collapse of these supports with subsequent failure of large portions of the roof under heavy fire conditions. Modern to heavy fire intents will quickly burn through the 2 by 4 inch joist and half-inch plywood or OSB sheeting, which can result in vertical fire travel and a reduction in horizontal fire spread. Additionally, when the craft paper insulation is subjected to fire sufficient heat, the foil covering will peel away from the upper layer of tar impregnate paper. The paper will give off flammable gases that rise and build up between the insulated paper and the decking. When the ignition temperature of these gases is reached, they can flash. Flat roof with an open web bar joist. Open web bar joist roof construction is found in a wide variety of buildings, large and small. It is predominantly common in the central and eastern state. However, it is replacing panelized roofs in the western states due to its lower cost and increasing scarcity of wood. The top and bottom cords are usually made from an 1/8 inch steel, and the web supporting are a solid 5/8 inch steel bar. Large buildings may have bar joist girders spaced up to 45 feet apart. The joists are spaced at 8-foot intervals with corrugated metal decking covered by melted asphalt, and then some type of insulated board, and then alternating layers of melted asphalt and composition. Strength. The strongest area of this roof is at the perimeter of the building. Hazards. Metal exposed to fire or sufficient heat between 800 and 1000 degrees Fahrenheit for steel will expand, twist, and likely fail. The time necessary for a roof collapse is a major concern when the entire roof is composed of metal. An additional hazard is the travel of fire between multiple layers of tar, paper, insulation material, or the corrugated metal decking. A more recent version of this roof uses a layer of ethylene synthetic rubber membrane to seal the roof from the elements. However, this roof performs in a similar manner to the older style roof in some cases, and even newer modifications use a non-combustible thermal layer between the metal sheeting and the insulation. Although this modification can have satisfactory results, it is unlikely that an IC will know what version is present. Flat roof, non-structural, lightweight concrete roof. To construct this flat roof, a steel or wood substructure is first covered by corrugated metal. Then a specific type of concrete, known as non-structural lightweight concrete, is pumped on top of the metal decking to a thickness of about 3 to 4 inches. To provide additional integrity, a 4 by 4 inch or 6 by 6 inch wire mesh is used in the layers of concrete. Composition roofing material makes up the final layer. Strengths. The strong area of the roof is at the perimeter of the building. The remaining portions can also be strong depending on the span of the roof. Hazards. Although the roof is strong, items of consideration are the span of the roof and what holds the roof up. Common vertical structure members are hollow 4-inch steel pipes and wood members. Lightweight concrete roofs are difficult to penetrate without specific equipment. Masonry blades are ineffective, so ventilation may require the use of a rotary saw with a carbine tip, wood blade, or multi-use blade. A chainsaw equipped with a carbide chain will also work but can be detrimental to the saw. Bridge truss roof. The bridge truss roof is a direct descendant of the bridge used to span rivers and gorges for the railroad industry, namely the Pratt truss and Howe truss. The same engineering principle is took to support a 40-ton locomotive could also be used to span great distances between walls or columns in buildings. The bridge truss is characterized by sides that are sloped from the exterior wall to a flat roof portion. The slope sides are derived from the trapezoid shape of the truss. These roofs are found on various types and sizes of commercial buildings and constructed during the historic and industrial eras. The wooden truss membranes are built from rough-cut, solid milled lumber of 2 by 12 inch size or larger, depending on the size of the building. This usually constitutes a heavy grade of construction. Vertical tie rods between the upper and lower chords may be used for additional support. Strength. Bridge trusses roofs are well constructed and are easily identified by their characteristic sloping slides and ends. When exposed to fire, early collapse of main structural members should not be an initial concern. In most cases, the bridge truss will sag prior to its collapse. In fact, there are many examples of bridge trusses still standing, even though the rafters and sheeting are totally consumed. This type of roof can predictably fail in sections depending on the type of fire. The strong area is at its perimeter of the building. Hazards. Its strength is dependent on the size of the lumber and the span of the truss. The trusses are in compression and tension and can fail under severe fire conditions. The underside of the roof is usually exposed in warehouse-type structures. Due to their age, roofs are likely to have multiple layers of some sort of composition material. Arched roofs. Oversimplified, the fire service text categorizes all arched roofs as either a bowstring truss roofs. The bowstring, however, is one of many methods used to achieve an arched roof shape. An argument exists that firefighters should treat all arched roofs as bowstrings due to the well-documented history of catastrophic collapse involving them. We get that. We can also argue that the tied arch is more dangerous than a timber bowstring. The four arched roof construction methods covered here have unique characteristics that could influence the firefighter operation. The lamella roof. Of all the older arched roofs, a lamella roof is not considered a truss roof, but it is definitely one of the most unique due to its method of construction and the amount of lumber that was utilized for its construction. Interestingly, this unique design was developed in Germany in the early 1900s and was first utilized in Los Feliz area of Hollywood, California in 1929 for the famous Brown Derby restaurant, which gave it its unique derby hat look. A lamella roof, also known as a summer bell roof, uses an egg crate geometric or diamond pattern series of structural members that help form a higher arch than the common bowstring roof. It is constructed of 2 by 12 inch wood framing with steel plates and bolts at the framing junction. The roof uses 1 by 6 inch straight or diagonal sheeting with composition roofing material. This type of arched roof is supported by three methods. First, the arches terminate on the foundation of the ground. Second, the roof is supported by exterior walls that are supported by exterior buttresses. And third, in a few instances, there is an internal tie rod with a turnbuckle. It is common on gymnasiums, recreational buildings, large supermarkets, and some buildings that may be considered medium size. Strengths. Lamella roofs are solidly built, possessing good construction techniques and lumber. The strong area of the roof is at its perimeter of the building. Hazards. Although these roofs can offer some protection, when exposed to fire, total roof collapse may occur if fire removes more than 20% of the roof structure. In this case, total collapse of the roof can result from a domino effect. These roofs will likely have multiple layers of composition material and will be difficult to ventilate unless an aerial device is available. Tied arch roof. Note, Chapter 3 featured a brief history on the arch truss. Although the tied, arch, and bowstring roofs are both arched, they have been different opinions regarding the nomenclature for these two roofs. The tied arch roof looks like a bow when viewed from the side, but it is not a true truss, as it lacks diagonal webbing. Although the tied arch roof is similar in external appearance to bowstring roofs and possible some lamella roofs, it is significantly different internally because in that it uses horizontal metal tie rods and counters the lateral forces that the arch top beam places on the walls. Tie rods with turnbuckles are used below each arch member to help achieve the counterforce. The tie rods may pass through the exterior walls to outside plates, which can facilitate identification of this roof, or they can be attached to the ends of each arch where it meets the wall. The steel used for the tie rod is ductile, meaning it can flex and move as live loads are gained or lost on the rooftop for this reason. The walls of a tied arch building are typically reinforced with a pilaster or buttresses where the arches sit. Tied arch identification tip. A tied arch is not a true truss. If a diagonal web members are attached to the arch cord and the bottom tie cord, the arch roof is a true bowstring. Some tied arch roofs have vertical tension rods hanging from the arch's top beam to add tension to the bottom tie rod or to support ceiling utilities. Strengths. This type of roof uses a large size of lumber and planks as the roof sheeting. The strongest area of this roof is at the perimeter of the building. Hazards. The primary hazard of this roof is early failure of the metal tie rods and turnbuckles. The tie rod provide lateral support for exterior walls and prevent the arches from pushing the exterior walls outward, thus thwarting collapse. Because this roof depends on the strength and security of its tie rods, failure may occur in sections that are exposed to fire. More likely, failure of any part of the roof can precipitate a total roof failure, depending on the type of fire. Compared to other arch roofs, the tied arch roof can offer significantly less structural integrity during fire conditions and should be considered very dangerous. Consider also the age of these roofs, and this leads to multiple layers of your composition roofing material. Now let's look at arch trusses. Also known as a rib arch truss or a ridge arch truss, the arch truss is a direct descendant of the bridge trusses we covered earlier, except for its shape. The first arch truss roofs used for buildings were all timber with steel plates and bolts used to assemble the wood pieces that formed the cords and the web. Usually large size, rough cut wood members comprised the arch trusses and related members. The bottom cord sits upon the load-bearing walls in an axial fashion, eliminating potential lateral wall forces from the arch. Arch trusses and bowstring trusses look very much alike, adding a level of confusion when conducting a pre-plan. Two clues that can help differentiate them. 1. A substantial bottom core that receives the top core and web members, and indicative of ribbed arches and trusses. 2. The abutment where the trusses meet the walls. If the bottom cord sits on the wall, essentially the top cord does not touch the wall, it is likely a ridge arch truss if no bottom cord tie rods have been added. The ridge arch truss roof is covered in the same manner as the bowstring truss roof, which is detailed coming up. Strengths. Like the bowstring ridge arch truss, using the large timber members and bolted connections, They are well constructed. When exposed to fire, early structural collapse should not be a primary concern like the bridge truss roof. It usually fails in sections depending on the type of the fire and the structural integrity of the roof. The strong area is at the perimeter of the building. Hazards. While the arch trusses have more inherent rigidity and stability than other arch roofs, it is still susceptible to collapse. All steel rib arch trusses are much like other steel trusses in that they are prone to rapid heating, especially if the bottom cord is exposed to burning content. Steel rib arches will try to elongate when heated. Arches that sit in wall pockets will try to push out the exterior blocks or bricks where they are attached. A collapse warning sign. Likewise, a rib arch that sits fully upon a wall can move outward and form a warning sign that is visible from the exterior. Timber ridge arch trusses can suffer the effects of aging. The bottom cord of the truss is especially susceptible. Bottom cords that show signs of splits or cracks are a collapse warning sign. Building owners often remedy cracked or split bottom cords by adding a tension rod that spans the bottom cord and is affixed to its end or to the abutment wall. In this case, the remedy has converted the ridge arch to a bowstring and should be treated as such. Finally, the bowstring roof. The original bowstring truss is a tied arch with a diagonal tension rod added to form a web. All the diagonal web members are in tension, whereas vertical web members are in compression, making the bowstring a true truss. The design for this popular type of roof was first used for arched bridges and then made its way into buildings by the thousands from the 1800s to the mid-1900s on both small and large commercial type structures. Although the original bowstring bridge was all metal, bowstrings used for roof construction can be all iron, all wood, wood and iron, and in later years all steel. Early bowstring truss roofs used large dimensioned timbers for cords, along with iron plates and bolt fasteners. A substantial roof. Likewise, the Hammond all-iron reverted bowstring trusses is considered the high water mark for bowstring truss strength. The bowstring truss made from smaller dimensions wood, all steel or steel wood combinations typically require pilasters or buttressed on exterior walls to help absorb lateral forces. Strengths. Bowstring roofs uses large timber members and bolted connections and are well constructed. When exposed to fire, early structural collapse should not be of primary concern like the bridge truss roof. It usually fails in sections depending on the type of depending on the type of fire and the structural integrity of the roof. The strong area is at the perimeter of the building. Hazards. Although most heavy wood roofs of this type can be substantial, the age and size of the lumber and the span of the arches determine the hazards. Some bowstring arches are comprised of iron, steel, or a combination. These roofs are often found on commercial warehouse type structures, the content of which may increase the risk of rapid exposure of fire to the underside of the roof structural members. Although the bottom cord of the arch trusses can be modified to allow storage in the attic, which can make ventilation and fire control and overhaul difficult. In addition to the aforementioned hazards, lath or plaster can be attached to the bottom cords of the trusses, further increasing the weight they must carry. As bowstring trusses are heated, they can move and place additional lateral force on load-bearing walls, to which the top cord is affixed. Often, it is a simultaneously failure of the bowstring truss and the load-bearing walls, hence the extreme caution and attention given to these types of roof during fires. If two bowstring roofs are connected together, there is a strong possibility of large open doorways that allow access between the adjoining buildings. This can allow the rapid extension of the fire between the buildings. Lastly, remember that the ends of the building with this roof can present a primary collapse hazard. If jack rafters have been used to slope the roof downward from the last truss to an exterior end wall, the end of the jack rafter will forcibly push the corresponding end of the wall outward if the end truss fails. Now for the unique roof construction considerations, you need to go through and read the chapter. I'm not going to read them all to you because there's quite a few and lengthy, but I will hit some of the high points. Older parallel core flat roofs look like older flat roofs, except they are more substantially built. The gable truss can be readily identified by its characteristic trapezoid shape and the fact that it will be found on older buildings. The bottom chord of older parallel chords and gable trusses can be converted to give a finished appearance to the interior. The older flat roof types typically have enclosed attic, cockloft, and the gable roof does not unless it has been modified. Older timber truss roofs are not always arch-shaped. They can also be flat or gabled. Timber truss roofs offer significantly more durability during fires than lightweight truss. Factors such as aging, multiple roofing layers, alterations, higher fire loads, and longer burn times are more responsible for timber truss collapses than the actual truss design itself. Fiberglass, aluminum, and steel roof corrugated panels can look the same from the street, but they will react differently when exposed to heat and fire. Use a roof ladder or aerial device to distribute the weight load if it is necessary for a person to be on a corrugated roof. If a corrugated roof has fiberglass daylight panels, they will quickly fail if exposed to heat or fire. One of the first indicators of a rain roof is roof ventilating personnel opening a roof and finding an abnormally large attic when one should not be present. The presence of a rain roof can give a false indication of a lack of heat and fire in the attic below the rain roof. In some cases, the appearance at the eave line can indicate the presence of a rain roof. Look for doubled coveraging roof lines. A rain roof can add an unwanted dead load to an existing roof that can lead to an early collapse of the entire roof assembly. Rain roofs are popular on mobile home type structures. Inverted roofs will always have a cockloft and necessitate evaluating for the presence of a fire. Due to the design of an inverted roof, the small members are underneath the roof sheeting and can be easily weakened by fire, which presents a notable hazard to roof personnel. As inverted roofs are generally older, expect multiple layers of roofing material on the roof. When we're looking at roof coverings, the first one they've got here is a hot mop. And the hot mop basically is where they take that melted asphalt and they use the mop and they spread it all across traditionally your flat roof. Now the problem with this melted asphalt is under fire conditions it can be extremely flammable. Oftentimes this asphalt was covered with some sort of rock or gravel material to make it more aesthetically pleasing. But that makes things heavier, so it increases our dead load, and it also makes ventilation quite difficult. Composition shingles. This is what we're primarily going to find primarily on our residential homes, especially here in Georgia. Usually it's those architectural asphalt type shingles that are good anywhere between, 20, 30, 50 years, depending on how much you want to pay. One of the problems with this particular type of roofing material is the fact that once they begin to leak, a lot of times individuals, rather than paying to have them removed like they're supposed to, will go ahead and slap on 2 or even 3 layers, depending on the age of the roof, of this shingle material, or composition shingle, as they call it. Again, the problem with that is the added weight to the roof, as well as making it more difficult to ventilate the structure during a fire. Wooden shake shingles are just that. They are wooden shingles that are nailed to the roof. Problems with this type of roofing is, even though they're aesthetically pleasing, they traditionally don't last as long, usually less than 15 years. And they can be a high fire load. Sometimes they're treated, sometimes they're not. But a lot of times with these things, once they start catching fire, then you run into exposure problems because they basically start floating off in the wind and landing embers and things on other structures and yards and creating a whole bunch of spot fires. Your clay tiles are very popular in some areas of the country because it gives it that Spanish style appearance. Florida, coastlines, things of that nature, you can see this style roof. And it's great in the sense that it can help control the interior temperature of the structure by 5 to 10 degrees. And it's non-combustible. The disadvantage, obviously, is these things weigh a ton, so it's going to dramatically increase the dead load on the roof. And if you have lightweight trusses underneath them, it may cause them to maybe prone to failure even quicker than anticipated. Also, ventilation is going to be a nightmare because these things are well seated and are extremely heavy, so trying to get through them can be a problem. And then, of course, an even bigger problem is individuals that are on the ground and they have these flying clay tiles coming at their head. So that can indeed be a problem. Your slate tile is actually pretty similar to the clay tile, with the exception that they are more expensive and a whole lot more heavier. So all your advantages and disadvantages are the same as your clay tile. Now you may remember when we talked about the concrete form walls and how they were started as a replacement for flat roofs. Well, here they are now in roof coverings with the concrete tile. And of course the advantage is that these things are, relatively new, and they have a variety of styles and can be of lighter weight material. But generally, concrete tiles are formed from the fiber reinforced timber products and feature long life with minimal maintenance. And they have lower weight than clay tile or slate and are non-combustible. However, they do create a big headache in terms that they have to be removed prior to ventilation. Metal roofing. Metal roofing has become more fashionable in recent years. You can see them pretty much everywhere popping up on your existing homes. And they're great in the sense that they're more energy efficient. They can help you with your energy bills. They're of lightweight nature. I believe the text says between 22 and 26 steel gauge, combined with non-combustibility. The problem with this can be obviously making entry and doing ventilation through the roof and being able to get on top of the roof, slip hazards in terms of water, as well as freezing rain and things of that nature. Another thing to be mindful of on these metal roofs is the edges, because a lot of times they're just cut and those edges can be sharp as razor blades. So definitely use caution in those areas. Finally, we have a single ply roof, and basically what those are is traditionally a flat roof that has multiple layers of insulation and things of that nature, and then it's covered with some sort of waterproof membrane or sealant. Now, the problem with this particular roof is it's great holding in heat, so it's very energy efficient. However, it may be misleading into the fire conditions below. Now, once fire gets into that roofing assembly, you're going to have a nightmare trying to pull up all the different layers to get to it and do in terms of salvage and overhaul. The fire spread is just unbelievable. And of course, with those multiple layers underneath, made of different types of polymers and plastics, you're definitely going to run into the release of those toxic gases that can always be present. Now, the first two I'm really not going to talk about here. The live green roof we covered in the eco-friendly chapter, basically, putting a garden on the roof or some sort of sod or wherever the case may be. Let's go green. Obviously, that had a lot of added weight. The monitor roof was the one that we talked a little bit about earlier in the chapter, where it can have that characteristic shape that can provide headroom, light, and ventilation to the interior of the structure. So it's kind of like, a bell, so to speak. So let's jump into division walls and talk about that for a second. Division walls are designed to partition a building and or minimize the horizontal extension of the fire and generally project at least 18 inches above a roof line. The important consideration to evaluate in a fire scenario is whether a division wall has been breached by the renovation, utilities, or for some other reasons. Those are basically, your fire stops or firewalls. You see them commonly in apartment complexes. And in theory, it was supposed to divide the various complexes. But as they said in the text here, when you start punching holes in them I've seen everything from AC to cable wire to sprinkler systems, your division walls kind of lose its integrity in terms of being a good fire stop. Chimneys and fireplaces, which are often used interchangeably, but in the text here they are a bit different. So the definition of a chimney is a structural component used for the venting of hot flue gases or smoke from a stove, boiler, furnace, fireplace, or other appliance. A fireplace is an architectural structure or appliance designed to contain a fire for heating and or cooking. Now, it's important to note that you have your masonry fireplaces, which exist made of the brick, stone, or concrete. Those are traditional construction type stuff as opposed to the zero clearance fireplaces, which is kind of follows that modern day lightweight mentality in the sense that those zero clearances, you have a little small opening for your fireplace, you have some heat resistant brick in there, usually they're gas logs, sometimes they allow for maybe 2 or 3 small logs to burn, and then the chimney itself is not made of masonry at all. It's usually just some sort of wood frame type lightweight structure with a metal tube running up through the center. Now the problem with these prefab chimneys, as I like to call them, is the creosote built up in the tube, and then once that tube gets rusted out, then you have all kind of fire spread into the chimney area where it's just that void space between that metal piping used for venting of the gases and the wood construction that surrounds it. The masonry fireplaces are definitely a bit more durable. Problems with those are they can crack over time and, of course, create little slits and openings where fire can creep out and cause extensions, but usually they're more durable. Also, when you look at the fireplaces, it can give you a good idea when the homes were built. Lightweight, modern versus legacy construction. Also, with the modern chimney, you've got to be very, very cautious in terms of that, or not modern, shooting the masonry chimney. You got to be very cautious in the fact that how well is the brick and mortar? Is it one of those older style mortar that is dissolved by water? Do you have loose bricks? If you hit it with a hose stream, is parts of the chimney going to start crashing down to the people below and create some sort of fall hazard? So those are just some things to keep in mind when dealing with your chimney and fireplaces. Your attic vents come in all shapes and sizes. They can be wall attic vents, ridge vents, turbine vents, turtle vents, you name it. And they're used obviously for venting of heat and sometimes gases and things of that nature. Oftentimes you can use these vent holes as a way to vent the structure just by removing the vent cover itself. Talking from personal experience though with those vent holes, be careful obviously when you're on the roof and sounding, but I did accidentally have a foot go through the roof by a vent hole, and it wasn't due to the fire, it was just due to rot where water was leaking around that vent and rotting out the plywood underneath. So again, just a near miss there, so you guys use caution around those things. Now for a cricket, I haven't seen one personally myself, but the text calls it this. A cricket is the junction of a vertical member, such as a skylight riser or parapet wall, and a horizontal member, such as a roof, where the intersection junction is covered by a roofing material. Its purpose is to keep water from running into and down the vertical member. Although this configuration delivers acceptable sealing, it also provides an excellent avenue for the extension of fire. When this condition is suspected, the cricket must be opened and exposed. Okay, so essentially this is a void space for the roof. And it's that little corner between the horizontal and vertical members of your roof. Air shaft and light wells. Air shaft and light wells were used in older buildings to provide light and ventilation to interior occupancies. Smoke issuing from an air shaft can indicate the location of a fire, and the shaft can also assist in the extension of a fire to upper occupancies. Also be aware that some air shafts have been covered over with material that may not support the weight of a firefighter. Look for a square or rectangle area that do not match surrounding roof material. And again, they go more into this in Chapter 9. Skylights, again, are another great way to ventilate the structure. Also, it's a good way to look at the interior of the structure and see how the fire is going or if it has spread. A lot of times, skylights can be over staircases and things of that nature. Penthouses are typically found on flat roofs and provide access to a vertical stair shaft that is common to the interior of a building. A good indicator of the status of the stair shaft can be observed when the penthouse door is opened. Finally, here on this slide, we have an elevator house which is a structure with the elevator may have different equipment on the roof. The elevator house can vary in size and shape depending on the age and when the elevator was built and its capacity. Okay, on the rest of these lovely roof appendages, you can see them over here on the little chart, or you can see them better on figure 8-36 on page 198. You have roof access or roof scuttles, you have your different vent pipes, you have again your ventilators, your fan shafts, your ducting, and even quite possibly advertising signs that can be on there. And with those advertising signs, they can of course fail and collapse, and they really add to the dead load of the roof. So under fire conditions, you got to be careful. You don't know even if the roof is rated to handle that. Okay, your chapter review exercise. Answer the following questions and even more questions. Again, you can find those in Blackboard. Make sure you answer them and cite your source in terms of in-text citation to make sure that you get full credit for the assignment. Okay, gang, if you have any questions, you can email me at aroberts@athenstech.edu, or you can give me a call in the office at 706-357-0162. Until next time, be safe and have a wonderful day.